All right, let's see real quick. 34. Let's do 34. Okay. Let's see who's working today. Green stuff is good. So let's see, it says sine of inverse tangent of 4/3. Oh, shit. Now, I desperately want you, real quick, little side note. If I told you that, cosine of theta is 4/7, and I ask you what tangent theta is, right? You with me? So like, okay, like, what would you do? This is an old problem. This is an old problem. What information does this give me? Anybody? What's cosine mean, fundamentally?
X over hypotenuse.
Yeah, x over hypotenuse. Can I draw a triangle? Of course, I can always draw a triangle, but what do you know about the triangle, given this?
The x and hypotenuse.
The x is, sorry? Sorry.
The x is 4.
X is 4, because cosine is x over hypotenuse. Please let that be that simple. We know cosine tells me the x side divided by the hypotenuse. So if they tell me cosine is 4/7, I know the x is some multiple 4, and the hypotenuse is some multiple 7. So I'll put a 4 there, I'll put a 7 there. So how would I get tangent? What am I missing? This side. Because I'll need to do y over x, correct? Is that cool? That's an old problem. We've done that. Look at this. Real quick. This is not the only way to write this. How do I solve that for theta? How do I solve any equation? If my variables has something being done to it, what do I do to undo that? You can do this. How do I solve any equation? That is cube root of x equals 7. What would I do? I love you guys. If I had a cube root of x equals 7, what would I do to both sides to solve that? Cube it. How does a cube and a cube root relate? How does a cube and a cube root relate? They're inverses. So of course we do the opposite function to undo this shit. So how do I solve for theta? What's the opposite function of cosine? Inverse cosine, right? So I would do, let me write this again. Come a second. I would do the inverse cosine of both sides. Theta equals inverse cosine of 4/7. This means the exact same thing as this. They're just written differently. It's sort of like writing it as a logarithm or writing it as an exponential. They both represent the same thing. So if I see this, I can draw this triangle. So if I see this, I can draw this triangle. So in this problem, where's there an inverse trig? Can I draw a triangle? Right, this is saying that if I call this theta, which you do not have to do, if I call this theta, this is saying that tangent theta equals 4/3. This is the same thing, just like we just did. I don't have to do that. If I see an inverse trig of this, I can set up the triangle. Tangent, 4/3. What's what? Say again? 4 is on the y? 3 is on the x, because tangent's y over x, correct? Yes, yes. So obviously at this point, and I know you guys, it's early, you guys don't like to talk to me, it's okay. But you have to have those at least memorized, right? Like the sine is y over hypotenuse, all that kind of stuff. You gotta know that. So if I tell you, if I give you information that means the tangent is 4/3, you can draw that triangle all the damn time. Okay. So what is this? Yeah, is that cool? I don't know if some of you guys know by now, there's a 3, 4, 5 triangle. It's one of the few where the sides are all whole numbers, right? There's also 5, 12, 13, 7, 24, 25, I think. Anyway. What's another way to get that besides just memorizing 3, 4, 5? Pythagorean theorem, who cares? So now can I answer the question, what is the sine of this angle given that it constructs this triangle? 4 over 5, done. Maybe? Yes, okay. Do you guys see that? It's old information, but it's just given to you in a different format. This means the same thing as this, and this is one of the very first things we did. Right? Especially if I can write a 3 like a 3, that'd be great. This is one of the very first things we did. I gave you this, and we set up the triangle. So that's exactly what inverse trig means. It means I want to set up a triangle that has an angle whose tangent is this. That's what that means. All right, so real quick, you guys try this. What do you got? Secant of inverse sine of 2, let's make it 5/13. Why not? I'll be nice. For some reason, that's the nice numbers. Do this one real quick here. Okay, let's see. What does the triangle look like? Let's look at triangle, Jeff. Good, good, good. What goes where? Where's 5 go?
The 1.
The y. Where's 13 go? The hypotenuse. And to figure out the secant, that's 1 over cosine, right? So to figure out the secant, I need hypotenuse over x. Did anybody get what x is? Do you guys see that? It's asking me for secant. To get secant, it's 1 over cosine. I need the x side. Pythagorean theorem. Did anybody do that? 12. Yeah. So it'll be 169 minus 25 is 144. Square root of 144 is 12. So 5, 12, 13 is another one of those really nice triangles. I want you to understand most right triangles, if you just set them up, they're going to have radicals somewhere. Right? But there are some nice ones like this. So what's the secant? 13 over 12, yes, thank you. Sweet. Can you check this in your calculator? Yeah, you can just put this in. Boom! You can just put that in. Now you have to know how to put secant in. You know how to put secant into your calculator.
Yeah.
If I want to do secant of something, well, we'll just do this. Secant is related to which other trig function? And cosine is on your calculator, correct?
Yeah.
So I would love it if it could be a cosine question instead of a secant question. So what is secant in terms of cosine? So this will be 1 over cosine of this. So if you put that in your calculator, and then compare it to what 13 divided by 12 is, you can check your work, right? There's not a damn thing wrong with checking your work. There's a lot wrong with letting the calculator do your work, right? That's the old joke I always say. Then your calculator passes the course, it has a great life, and you have to retake it. That sucks. Now, real quick, word about the first few. Do you see how there's a difference between the first few and the last few? These that we've been doing, the inverse is inside. On the first few, the inverse is outside. Can anybody tell me what the sign of pi is? Look at number 25. What's the sign of pi? What's the sign of pi? Okay, so let's talk. All right. I'm disturbed. You're like a trig disturbed. So you have to either just straight up memorize this stuff. So I've said this a few times. So by now you have to have it. You have to either just straight up memorize these things, or you have to have a way like I do. I don't have any of this shit memorized. Sine likes y. Where's pi? Where do I end up if I go pi? 180. So where do I end up? On the which axis? X-axis. Is sine happy there? Hates it. So what's sine of pi? 0. Beautiful. That's exactly what I think. When somebody asks me a trig thing, I do that in like 3 seconds. Instead of memorizing, I don't have that much brain space. I don't have a lot of other shit in there. All right, so that one, number 25. Sine of pi is 0, then the question really is tangent of inverse of 0. So when is the tangent equal to 0? Say again? No, because tangent sine over cosine. If cosine's 0, then tangent's infinite. Right? So tangent is 0 when sine is 0. But you got to be careful. All right. So, let's do this. So this becomes inverse tangent of 0. Tangent is 0 when sine is 0. Right? Now the funny thing is, if you plug this in your calculator, which is complete, does anyone have their calculator? If you plug this in your calculator, what does it tell you? Because tangent is 0 when sine is 0. Sine is 0 at 0 degrees and pi degrees. All right, not pi degrees, pi radians. I love it, John. Yeah, it does tell me 0, because that's what it's going to assume you mean. All right, so so that's really a question. Those first few are, do you know what sine of pi over 3 is, for example? And then can you work backwards? So if I just straight up ask you, inverse sine of 1/2. How do you evaluate that? What do you have to think? Anytime you have an inverse function, you have to think backwards. So this is really asking me, what angle makes sine 1/2? That is what that's asking. What angle makes sine 1/2? Say again? Pi over... God that could be either 6, yes, thank you. You're 6 down on like 3, it was weird. Okay. Or if you could put in degrees, that would be 30 degrees, right? Sine doesn't like x, so it's small when it's close to x. 30 degrees or pi over 6. Do you guys understand that? So you have to know how to evaluate inverse stuff. It's just, in fact, again, how do you evaluate log base 3 of 81? What do you think? Don't you think backwards? We think what power makes 3 become 81?
That's a maybe.
Maybe? 3 to the maybe equals 81, okay. So this is the same way, it's an inverse sine. So it's saying what angle makes sine become 1/2. That's how you evaluate inverse trig. Almost any inverse function we have to think backwards. Okay. What's the square root of 49? Why? Because 7 squared is 49, right? I mean, that's how you think about a square root, is what does it take 2 of to make this, right? You think backwards about it. Okay. So, the less you have the angles and values memorized, the more impossible that becomes. Because if you don't know what sine of pi over 6 is, there's no way in hell you can answer this question. Because you got to think backwards. Okay, maybe. Okay, all right. Anything else from homework stuff? All right. Okay. So I think what I'll do, I kind of want to do this. Sure, I don't normally do this, but I don't care. Tomorrow, first thing, we're going to have a little quiz where everybody's just going to take out a piece of paper, and I'm going to say, like, what's the sine of pi over 6? And you guys are going to write it down, and then you turn it in. Right? No, obviously no calculators, no phones, none of that, anything. You with me? Okay. Don't come. That's silly, because then you miss the lecture and you get behind, and then you're even worse off. That's crazy. Instead, memorize or come up with a way to remember how to get it. You need this. You need to be able to do it. Okay, maybe. If there's nothing else from homework or anything, we're going to get into some more trig identities. Can anybody tell me one of the identities we learned yesterday? Like the most basic one. What was the most basic identity?
Sine squared of theta plus cosine squared of theta equals 1.
I love it. Now let me test a couple things about that, because it's one thing to learn identities, it's another thing to know how to really use them correctly. So let me ask you a few quick fire questions based on this. Can somebody tell me what cosine squared A plus sine squared A is? 1. Right? The variable doesn't matter. As long as something is true. So what about this? What's sine squared omega plus cosine squared theta? Say again? Did you say it's 1?
Yeah.
Nope.
Nope, why not?
Huh?
Why not?
We'll say it in a minute. Does anyone see why that is not 1? And I don't know what, it could be 1. I don't know. I have no idea what that is.
Is it because you have omega and theta?
The angles are not necessarily the same. That's huge. The angle has to be the same. And why does that make, please, where did trig functions kind of live when we first create them? Where do we really get them from? We get them from this unit circle, correct? The equation of the unit circle is this. In order for this equation to be true, the x piece and the y piece have to come from the same triangle that's in there, right? So omega could be over here and theta could be over there. I mean, there's no reason they have to equal 1 then. They're not at the same point. They don't have to make this true. So when you see an identity, you have to realize things like that. These angles must be the same, or else who the shit knows? Right? In fact, real quick, what's sine of pi? 0. What's cosine of pi over 2? 0. So sine squared pi plus cosine squared pi over 2. Is that somehow magically 1 now? Of course not. It's 0 plus 0, correct? Do you guys see that? So if the angles aren't the same, it could be any freaking thing. I don't know. But if I'm talking about the same place on the unit circle, cosine squared plus sine squared has to be 1. That's just Pythagorean theorem. That's it. Okay, maybe. Okay, I like it. Then we built 2 more things off of this. And the way I remember it, I sort of remember now, obviously I've been using it so damn much that I sort of have memorized them. But when I first learned this, I didn't memorize the other 2. If I divide this by cosine squared, I'll get tangent squared plus 1 equals secant squared. I love it. So you can memorize that. You can do what I just did. Whatever. I didn't try to memorize it. I've just used it so damn much. I know it now. Right. Okay, I like it. And then, of course, we got the other one that's kind of beautifully analogous to this. Yeah, 1 plus cotangent squared equals cosecant squared. It's crazy. Okay, so that's one big thing we discussed yesterday. This is huge. It's huge. Right? Sort of like the results from yesterday. Huge. Okay. Okay, I like it. Okay, and of course, we also discussed in the inverse stuff, which we did some of. So that was yesterday. So let's talk about today. Okay. And by the way, we're going to build some more identities, and then I am going to bring and give you this handout. It's going to be crazy important. I told you about it once. It's got all the trig laws that you're going to see this semester, anywhere this semester. And I'll tell you exactly which ones you have to memorize, or at least be able to get when you need, and the ones you don't have to memorize. Right? So if I ask you a question about the ones you don't have to memorize, I have to give you the equation. That makes sense, right? Because I don't have those memorized. I'm not going to make you do it. Okay. Today's going to be, all right, today's one of my favorite things. I don't know how that makes you feel. Does it make you worried or anything? Probably, maybe. I don't know. Yeah, like, just get on with it, man. All right, sorry. I want to know if there's a way to figure out what sine of, for example, A plus B. One thing I really want to make sure everybody understands, it makes 0 sense to say, oh, just distribute the sign. That is insane. That doesn't make any sense, right? What's the square root of 4 plus 9? It's the square root of 13, right?
Yeah.
It's not the square root of 4 plus the square root of 9. It's not 2 plus 3. It's not 5. Correct? So I can't distribute a square root symbol because I'm taking the square root of all the stuff. I'm taking the sine of all this stuff. Are you guys semi with me? Are you guys with me at all? You guys are here. Okay, good. That's a good baseline. We're also going to investigate cosine of A plus B. We're going to investigate sine of A minus B, cosine of A minus B. We're going to get 4 more identities. Right? And in fact, just to warn you, instead of the letter A, I'm going to use the Greek letter alpha. And remarkably enough, instead of the letter B, I'm going to use the Greek letter beta, because you're going to see those letters, and I just want to start getting you used to those. It's just Greek letters, right? Math people, we love those Greek letters. Just like W. W, technically known as omega, that is a Greek letter, right? And of course, not to relive this, but why do people know more Greek letters now?
Sororities.
Huh?
Sororities.
Sure, that's been forever, but what happened recently that maybe helped us understand some Greek letters? You guys know?
Pandemic.
The pandemic, the variants, right? Omicron, Delta, Alpha, they're all Greek letters.
Right.
Maybe you didn't realize that, but that's what those are.
I thought they read that up.
Say again?
I thought they read that up.
Yeah, you'll want to join those sororities, yeah. Or fraternities. All right. So, all right. Let me really make sure you understand what's going to happen today. We're going to do a lot. We're going to do it together. We're going to prove, we're going to construct these things. That is what we are going to do. You are never going to have to do it yourself. We're going to go through it. We're going to construct it. I'm going to hope you follow me, because I really want you to see where these things come from. We didn't just make them up and go, that sounds good. No, it's just what they come out to be. So we're going to do that today. So how in the world, so let me write this the way we're going to see it. So if I want to figure out what sine of alpha plus beta is, doesn't it make sense to set up a triangle that has alpha plus beta in it? Maybe? If I want to know what that is, don't I just try to set up a triangle that has alpha and beta in it? Right?
Yeah.
Okay. And well, okay, let me get this. Okay. Well, this is gonna be fun. Don't worry about this side. There's a side that's got a bunch of identity work we're gonna do later. Do this side. Ooh, triangle, big ass triangle. Alright, so don't worry about the identity side. Worry about the triangle side. So I really want it to make sense why this is set up the way it is. This is not the only way to do this, by the way, to prove these identities, but it's the way I like it. So that's what we're going to do. Let's see. All right, let me see. Oh yeah. This guy. Okay, good. All right, guys, let's see. So I really want this to make sense. So I've got this right triangle here, right? This one. It's got an angle of alpha, right? Then I've got this big ass right triangle that's got alpha plus beta. So this must be beta then. You guys all see that setup? Okay. And this lives in the unit circle, so that's 1. This to here, that's 1. Okay. So, let's do this first. I think this might be one of the easiest things to do. Yeah, well, there's a couple things we could do. Let's do this first, yeah. So do you see that's right triangle here? The one that's got beta in it, right? Is that cool? So I want to just focus on this triangle, that's the one that's got beta in it, right? Okay. So this one. Yoo-hoo. we can all do this. What would cosine of beta be? So let's say this is x and this is y, right? What would cosine of beta? What's cosine of beta? No, you guys can do it. Cosine of beta, what's it defined to be? Yeah, so it'll be x over 1, so cosine beta equals x. Are you guys with me? So that is cosine beta. This side right here is cosine beta. You're going to die, aren't you? Poor little dude. No. Yes. All right, that's our first step, our first little step. Okay, I like it. Now, can anyone tell me what, let's see, let's do, okay, let's do this one. This is the next one. This is the one I was going to do first here. Look at this big ass triangle here. Right? So by the way, this is all of this. This x cosine beta is all the way, right? So look at this big ass triangle right here. Okay. Let's do the exact same thing we just did. So here's x. This will be y for it, right? This whole thing. So what is x going to be? What would cosine of alpha plus beta, what would that be in this big ass triangle here? What's cosine? Yeah, so cosine of alpha plus beta would equal x over 1. So this is the same, exact same way I got in this other triangle. This is cosine of alpha plus beta. Right here. So this is cosine beta. Okay, all right. And by the way, yes, this is what it's going to be like for the next few minutes. This is really exciting. Just try to keep up and realize you don't have to do this yourself. I really want to make sure you guys kind of agree with me where things are coming from. Come on, Pen. Work with me. Okay. Okay. What about, all right, this is going to get a little bit trippier. Let's look at this bottom right triangle here. Yeah, okay, this will be interesting. Yeah, this one, this big one right here, this bottom one here, this guy. What angle does it have in it, this bottom dude? Alpha. What is this guy's hypotenuse? Cosine beta. Okay, I love it. So this is the first time. It doesn't matter what the hypotenuse is. If I'm asking you for sine, you would put y over a hypotenuse, whatever the shit it is. It's just, this is the kind of the first time we've seen the hypotenuse itself is cosine of beta, right? Who cares? It's just a number, right? Just a number. So can somebody tell me what this is going to be? So I'm in this triangle here. There's the hypotenuse. What is cosine of alpha? So we'll call this x2. This whole thing. Okay, again, so just focus on that one right triangle we're looking at. We know what his hypotenuse is now, this big ass dude at the bottom here. What is cosine of alpha? X2 over cosine beta, right? So isn't x2 equal to, if you multiply this up, isn't this equal to cosine alpha, cosine beta? If cosine alpha, right, and again, nothing big about this. Cosine is just one side divided by another side. That's all it is. So cosine of alpha is the hypotenuse divided by this. no, sorry, this divided by hypotenuse. Why am I thinking about secant? So it's this divided by hypotenuse. So I get x2 divided by the hypotenuse, which is cosine beta. Can't I solve for x2 then just multiply this up? Okay. And again, would any of you have thought to do this? No, I wouldn't even, as a student, have thought to do this, right? I mean, why the shit would I think to do this? But hopefully so far it kind of makes sense. We're doing one step at a time. I got multiple right triangles, some of them sharing sides, so I can make all these relationships. Okay. Let's see. Oh, good. What about this? We're still talking about the same triangle. Same triangle. What about this? Let's call this y2. What's the sign of alpha?
Y2 over cosine beta.
Yeah, it'll be the y side divided by the hypotenuse. So isn't y2 equal to, just multiply this cosine beta up? Isn't this equal to sine alpha cosine beta? So this is equal to sine alpha cosine beta, right here. Again, all I am doing is continue using over and over the fact that the trig functions are just ratios of sides. So the minute I know what a side is, I can construct a ratio, and that's equal to another trig function. That's all we're doing. Nothing amazing here, to be honest. At the same time, I love this shit. Maybe. All right. Let's see. Yeah, okay. Thankfully I've got a little thing to keep myself straight. Yeah, let's do, oh yeah, there was one more thing I could do with this big ass triangle here. I don't know why I didn't do it yet. This big ass triangle here, right? Sorry, this big ass triangle here. So get the y side. What is the sine of alpha plus beta? That's the angle that's in this big ass triangle, right? What's the sine of alpha plus beta? This big ass triangle here.
Y over 1.
Y over 1. So y equals this. So this whole thing, let me see how I can do this. Sine of alpha plus beta is this whole thing. By the way, I am going to give you a handout that's got the finished result of this. You with me? But I do kind of want you to go with me on this. That's why I gave you a blank one. But you will get a finished thing here. Okay. Let me see. What else do I want to get? Yes, let's do this weirdness. Okay. Here's a nice one. Okay. This is another one I could have done earlier, but it's really weird to figure out the order to do things in. Let's look at this triangle again. This one. What angle is in this triangle here? Beta. Right? So what is sine of beta?
Y over 1.
Yeah, this y over 1, right? So this y is just sine beta. Okay, and again, I know this is not amazingly exciting shit. I know it is. Everything we've done is just based on the fact, I know I keep saying this and I don't care, that trig functions are ratios of sides of triangles. Every single thing we've done so far has just been that. That is it. So on one level, this is all like, well, who gives a shit? And of course all this is true. Let me see, is there anything else I left out for this step? One more thing. Oh, I got that, okay. Okay, one last thing here. I've got like intermediate step that I'm gonna swap out that has typewritten stuff instead of my handwriting, so it's a little easier to follow. But I wanna get to a certain point. Watch this. Trig, when you're dealing with trig, what kind of triangle do you hope you can find?
Right.
A freaking right triangle, right? Yeah. Give me a nice different color here. There we go. See if this shows up. So look what I can do. Watch this. I'm going to make a right triangle right there. Why am I allowed to do that? Because I can. Nah. I can do that any damn time I want to. I can draw a line inside of a thing and make a triangle. If it helps me, that's a good idea. If it doesn't help me, I can still do it. But do you see how I have information about that triangle? Don't I know what that triangle's hypotenuse is? Okay. So the real bad thing right now is, do I know any angles in that triangle? I have no idea. I only know one thing. This. I know the hypotenuse is sine beta. That's all I freaking know. Shit. So, how do I figure out? I want to know what this angle right there is. I want to see if there's a way to figure out what that angle right there is. Okay, so let's see if we can figure this out. So if I kind of knew what this whole angle was, that might help me out a little bit. You guys with me? Does that make sense? At least that would have part of what I need to know, right? So could anybody figure out what this whole angle here is? What's down here? This is a right angle here, right? And this big ass triangle here, that's a right angle. This is beta, right? So this whole angle must be, I think I heard it, 90 minus beta. If I knew one angle is 90 and one angle is 10, doesn't the third one have to be 90 minus 10 to make 180 total? All right, so I know this whole angle here is 90 minus beta. Okay. So how does that help me out? Well, let's see. What else do I got? Oh yeah, what's this angle here? Yeah, 90 minus alpha, right? Okay, let me see. What else will help us out? Bum, bum, bum. Oh, even better. So what's this angle here? Oh, this is a much more direct route, Jeff. Okay. I didn't even remember how to do this. So I'm doing it live. Isn't this the same idea? Isn't this a right angle here? And that's alpha. So this is also 90 minus alpha. Are you guys with me? If alpha is 10, this has to be 80, right? To make 180 total. So that's alpha, and that's 90. That must be 90 minus alpha. This is getting, I'm getting to the point where I have to switch over because this is getting really kind of clogged up. But just 2 more steps and we're there. Do you guys remember the angles that are made by crossing things over? Here, Jeff. This angle and this angle, how are they related? They're equal. They're vertex. Right? Because they make a letter B. So this would be 90 minus alpha. Okay, so let's put this together. I can now get what that is. If this is 90 minus alpha, and this is 90, what does this have to be to make it 180? So I got 90 minus alpha plus 90, and I need to end up with 180, right? So far I have negative alpha. Well, no, I don't. I have 180 minus alpha. So what does this have to be? So when I add it to this, I get 180. Alpha. Okay. So all that work just to get some angles in this triangle here, right? All right, let me swap this out with, yes, okay, here we go. I think this has everything we've done. Let me make sure that I didn't miss anybody. No, I got everything. Yes, yes. Okay, here we go. I'm going to swap out my horrible handwriting. There. So that's basically where we are now. That's everything we just figured out, just written with a computer, so you can actually read it. I really hope somebody out there is kind of like, this is like, you know, some amount of interesting. I don't know. Okay. So, what else can I do now? Well, let's see. Can't I figure out what this is? Let's see. So here's my right angle. This angle is alpha. I know that hypotenuse is sine beta. So can I figure out what this is here? Let's see. Let's turn it like this. So I want to figure out what this is here. Right? Let me call it W, just to use a different letter. What trig function would relate this angle with these sides? Say again? Sine. So what is sine of alpha equal to from this triangle? W, I love it. Thank you for using over sine beta, right? So what's W? Sine alpha, sine beta. That would be this here, right? So let me just put it, isn't this the same as that? Aren't these two the same? This little rectangle here, is that cool? So I'm just going to put it right here. This is sine alpha, sine beta. Stop using that one, Jeff. Okay. Let's see. Okay. I got you. Okay. So then what's this side going to be? Well, again, I can look at it like this. Let me call this one, let's just call this one M. Like the, like W flipped over, right? So now I can say cosine alpha equals M over sine beta. So then M equals cosine alpha sine beta. I know at this point, some of you guys have completely lost. Some of you guys, I don't know if anybody's completely tuned out. And again, every step we've done has just been set up the ratio, right? Whatever the side is, it's involved in the ratio. That's all it is. So now I know this is cosine alpha sine beta. Okay, what else do we not know yet? Let's see. So I got this. I think that might be everything. Let me see. Yeah, okay. I got everything I need. Okay. Believe it or not. Now look. Look at just the bottom of this triangle. What is cosine alpha plus beta plus sine alpha sine beta? And again, I know I just said a lot of shit. What is that little piece plus that little piece? What does that equal? The whole piece, right? The whole thing. One chunk plus the other chunk is the whole damn thing. So this chunk plus this chunk equals this chunk. So I now know, Jeff, I now know what cosine of alpha plus beta is. And if I just subtract this, what did you just do, Jeff? Oh, yeah, you're fine. Oh, yeah, come on, Jeff, you can do it, buddy. I'm looking at this thing sideways. All right, so this plus this equals this. Bam. So now if I just subtract this, I know what cosine of alpha plus beta is, which is what we were trying to get to earlier. Okay. So trust me, oh my God. Obviously, that was a great demonstration of how easy it is to get lost. There's a lot kind of like going on here. You never have to do this yourself. I just need to show you where this stuff comes from. We didn't just make it up. It's just the way it works. Can't I do something similar this way? What is sine alpha plus beta? Isn't it equal to this plus, it's upside down, but this plus this? Isn't equal to this piece plus this piece? Yes? So it's equal to sine alpha cosine beta plus cosine alpha sine beta. Oh my God. Okay. I love you guys. We're basically done, believe it or not. We just got expressions for sine of alpha plus beta. We know what it is in terms of the alpha and the beta. And cosine of alpha plus beta, we know what that is. Okay, so let me show you something kind of nifty so let me kind of summarize what we just did, and I want to show you something kind of cool. So we just figured out sine of, let's use something different than alpha and beta. Sine of A plus B equals sine A cosine B plus sine B cosine A. That's basically what we just figured out. And we figured out cosine of A plus B equals cosine A cosine B. Yeah, like plus minus sine A sine B. So I want to point something out, and some of my colleagues have accepted this. I noticed this not when I was a student. I think it was like when I first started teaching trig. And it's remarkable how far this idea goes. And this is going to sound really silly, and I don't care because it's really helpful. Okay. Cosine is an asshole. Cosine is a little jerk. What do I mean by that? It's going to help you memorize so many things. If you have to take calculus, that idea is going to continue, believe it or not. It's going to show up in a few other places. What do I mean? Look at what sine does. Sine says, oh, you want to know what sine of A plus B is? Well, let's take turns, cosine. I'll do A, you do B. We'll keep it plus, right? And then we'll switch. I'll do B, you do A. So sine is nice. You got a plus, I'll leave it a plus. Let's take turns. Look at cosine. Cosine of A plus B. Me first. Ah. No? Yes? I don't know. I'm trying. Right? Cosine's like me first. Cosine A, cosine B. All me. You got a plus? Screw the plus. Make it a minus. Now it's your turn, sine. Pick up the leftovers. Right? Maybe? I don't know. Just trying to give you a way to memorize this. Right? And like I said, it's kind of amazing. It seems like every semester I learn a new thing that kind of falls into cosine is a jerk and sine is a nice guy. Okay. I don't know. And let's see if you guys remember this real quick. Does anyone remember what sine, Jeff, can you write? What sine of negative theta is? That was one of the ones we talked about yesterday. And the way I remember, think about a unit circle. So if you have sine of 30, isn't it positive? If you have sine of negative 30, isn't that negative, right? So this is equal to negative sine theta. You with me? That's going to come important in a second. And what's cosine of negative theta? Well, the same idea. If I have cosine 30, it's positive. If I have sine of 30, it's actually, cosine 30. If I have cosine of negative 30, it's actually the same thing. It's still positive. It's still somewhere where the x is positive. So cosine of negative theta equals cosine theta. This was the odd symmetry and the even symmetry. So watch this. Two things. Okay, so we got that. Coming back up here. Real quick. Can somebody tell me what sine of W plus T. Can somebody tell me what that is?
Sine W cosine
Sine W cosine T, right?
and
Plus
sine T
sine T.
cosine W.
So what's the idea of this identity? The sum of two angles is sine of one cosine of the other plus sine of the other cosine of one, right? Just, that's the idea. I don't care what they are. That's how it's rewritten. So what is sine of A plus negative B? Also known as sine of A minus B, right? Sine of A plus negative B. Same idea. Let's do it. Isn't that sine A cosine of negative B plus sine of negative B cosine A? Now remind me, what's cosine of negative B? Cosine B. What's sine of negative B? Negative sine B cosine A. Do you see how the idea still holds? Sine says, oh, you got a minus? I'll keep it a minus. Oh, you got a plus? I'll keep it a plus. Are you guys with me? Again, I'm just trying to give you ways to help you remember these things, right? All right, let's do the same thing with the cosine. What do you got here, Jeff? Here we go. What's cosine of A minus B, which is cosine of A plus negative B? It'll be cosine A, cosine negative B. Is that cool? Minus sine A, sine negative B, right? This would be cosine A. Cosine of negative B is still cosine B, yes? But sine of negative B is negative, so that makes this plus sine A, sine B. So cosine continues to be a jerk. Oh, you have a minus? I'm going to make it a plus. Nah.
Sine A was negative.
Say again? Well, that would be a different, then I would have cosine of negative A plus B, right? Okay. Does that make sense at all? A little bit? No? Screw you, Jeff? So let me give it to you in one more way, just so to make sure you really get this. Sine of theta plus W. So what do I think when I see this? Sine is a nice guy, so it's going to take turns. I'll do this one, you do the other one, cosine. We'll keep it plus because we're nice. And then I'll do this one and you do the other one, cosine. Okay, we'll work together, right? Cosine of theta plus W, omega. What would that be? Cosine theta, cosine omega. It's like me. You got a plus? Screw you. And then sine, now you do it, sine. I'm all done. You go ahead and do your thing. I'm cool. Okay. And again, we didn't just make that shit up out of nowhere. We didn't just go, oh, that sounds good. Let's make it equal to that. No, it actually came from how they interact. Okay. So how can I use this, Jeff? How is this useful at all, Jeff? Well, here we go. What if I wanted to know what sine of 17 degrees cosine of, what do you got, buddy? Let's do that. 28 degrees. Plus sine of 28 degrees cosine 17 degrees. What if I had to know what that was? Let's see, yeah. Isn't that in this form? So what is this equal to?
Sine 17 degrees plus sine 28 degrees.
Yes, so it'll be sine. This is equal to. So this is sine cosine plus sine cosine. Okay, so it must be a sine of these two angles added together. Jeff? No, you're fine, Jeff. Good job, buddy. What is 17 plus 28? 45. And what's sine 45? Rad 2 over 2. Completely undoable before today. Doable now. Now, real quick. That's kind of lame, just to be completely honest, right? How often am I going to have to know what sine 17 cosine 28 plus sine? Not very often. Maybe like a little more often than you think, but not very often, right? The real power of this is what it leads to later. In fact, not later, right now. Here we go. Let's do this. Okay. In fact, let me give you this first. Here it is. Okay. This is the nice, neat, finished thing with the collection of all the identities at the bottom. So, I just collected, here's kind of like the stuff showing the even and odd symmetry stuff and so forth, and then at the bottom I just collected this together. So we're going to prove these right now. These double angle identities. Don't worry about tangent, by the way. He's a freaky little dude. I don't know, how would I, if I know sine and cosine, how would I get tangent? Wouldn't I just take this divided by this? And believe it or not, if you work with it, it becomes this. I might make that a bonus question, we'll see. So let's do this. If I wanted to know what sine of 2 theta is, how can I write that, of course, as a sum? Because I know how to do sine of a plus b. So how do I rewrite sine 2 theta as a sum?
Sin theta plus theta.
Theta plus theta. Cool, right? Okay, and now we just follow what sine does, right? What sine of, so sine of alpha plus beta, whatever they are, doesn't matter what the shit they are, it's sine of the first dude times cosine of the second dude, right? Plus cosine of the second dude, sine of the first dude. Because they're the same angle, don't I have like terms now? What do I have here? Can you combine those? Isn't that one sine cosine plus another sine cosine? What's that? What's one thing plus itself? Isn't that just twice? Right? Maybe? Screw you, Jeff.
It doesn't matter what order they're in.
What order, what's it?
Sine
Oh,
and
of
cosine.
course not, because it's multiplication, right? 4 times 7 is the same times 4. Right? Isn't 4 times 7 the same thing as 7 times 4? So, like, for real quick, if I had xy plus yx, are those like terms? Of course they are, right? So I have sine theta cosine theta plus sine theta cosine theta. So I have 2 sine theta cosine theta. Maybe. You guys try to do cosine 2 theta. Do it. You can do it. I know you can. Don't just look at the answer, by the way. We're gonna get there. so let's see, cosine. Let me do it like this, yeah. So cosine of 2 theta is cosine of theta plus theta. So this will be cosine of the first guy, cosine of the second guy, minus, good, sine of the first guy, sine of the second guy. So what's cosine times cosine? Cosine squared, holy shit. Minus sine squared. Now, that's not where this ends. And again, here's a beautiful, I really want this. There are 2 other ways to write that. There are 3 options for cosine of 2 theta. Cosine, you are a jerk. Sine of 2 theta, 2 sine theta, cosine theta. There you go, buddy. One option. You don't have to choose. And cosine goes, all right. Here, this or this or this. Good luck. So we're going to develop 2 other things for this. And again, I'm just trying to show you how cosine is a jerk. Okay. So watch this. So here's one thing. This is valid. This is done. This is great. Can anyone tell me what cosine squared is in terms of sine squared? What's the most basic identity? Sine squared plus cosine squared equals 1. So if I solve for cosine squared, don't I just subtract sine squared? So isn't cosine squared equal to 1 minus sine squared? And don't I have another minus sine squared? So isn't this 1 minus 2 sine squared? That's also true. That is also what cosine of 2 theta is. So cosine of 2 theta is this. It's also this. And it's also, what the shit? Can't I solve this for sine squared? Wouldn't it just be 1 minus cosine squared? Wouldn't I just subtract cosine squared to solve for sine squared, right? So look at this again. If I start here again, cosine 2 theta equals, you could do it, Jeff. Cosine squared theta minus 1 minus cosine squared theta. Because sine squared theta is 1 minus cosine squared theta. So cosine 2 theta is also cosine squared minus negative cosine squared is 2 cosine squared theta minus 1. There's a third option for it. God damn it. So here they all are, down here. So cosine 2 theta is this, it's this, it's this. Depending on the situation, one of those 3 might be the only thing that works, or it might be easier to use it that way, so you just have to figure out which way to do it. Do you start to see what I mean by cosine is a jerk? And again, cosine is not an entity. It's not an organism. I know it can't be a jerk. It's just a way to remember some shit, right? Sometimes I have students like, how can cosine be a jerk? It's just a freaking thing. Yeah.
So for those 3 are all the same answer? Or?
Yes, they all are equivalent. They're all equivalent. The same way that 5, isn't 5 1 plus 4?
Yeah.
Is that the only thing 5 is?
No.
Isn't it the square root of 25?
Yeah.
And so forth. I mean, I can, just keep going forever.
So it's like we can end up with that any way possible, or?
So all 3 of those are equivalent. So if I had a problem that said, write everything in terms of cosine theta, wouldn't I choose the second option? Because that's the only one that doesn't have a sign in it, right? Or if there's a problem where if I make everything cosine, it's easier, I would choose the second option, right? So depending on the situation, one of those 3 options might be better. Now, some situations, it doesn't matter. Who gives a shit? But a lot of situations, one of those 3 will be better. Or the only possible thing, sometimes. Yay. Okay. So, now, what I want you to do is, it's going to be great. So remember this beautiful blank paper I gave you? Remember the other side had problems? So I want you to do this. I want you to do those problems. And I want to, let's do the first one together, just to kind of get on the same page, and to kind of see the way to think about these. Look at the first problem. Does anyone have a suggestion? So the idea is I am just using anything I can. Any identity I have, I'm going to try to use it. And the way identities work, you pick a side to start working on, and you start working on that. You with me? Because what do I need to show? I need to show that one side becomes the other side. That would show that they are equal. Is that cool? Maybe? Okay, all right. It's not cool. Does anyone have a preference which side to start working on? All right, you want to do it, so you have a suggestion on what to do?
No.
Well, then why does you have it? So let me ask this in a different way. Does anyone have a side they see they can do something?
The right.
Okay, so so it didn't mean the left was wrong, but what could you do on the right?
You can convert secant to
All right, I love it. Okay, so let's see. So one thing I could try to do, so you're doing the thing where you make everything in terms of not just cosine. What's secant? 1 over cosine. And what's tangent? Sine over cosine. Okay, now, on one level you would say, we just made this problem worse, right? But don't those at the bottom have like denominators? So can't I combine those? So what do I get on the bottom then? And again, we started on this side, didn't we? Can anyone see why I feel really good about where I am at the moment? Doesn't this side have a 1 minus sine x on it? Didn't we just uncover a 1 minus sine x? Okay. What really sucks about the way this is written? It's not just a fraction, it is a fraction inside of a fraction, correct? Read this to me. Doesn't it say cosine x divided by this?
Yeah.
How do I divide by a fraction? Multiply by the reciprocal, right? So this will be cosine x times the reciprocal of this. And if you remember, this is over 1. Is that cool? So cosine x divided by this is cosine x times the reciprocal. And what do you get there? Yeah, cosine squared over 1 minus sine x. Isn't that what it was supposed to be? So when you make one side look like the other side, you're done. Is that the only way you could have done this problem? No. That is not the only way you could have done this problem. How would I have done this problem? Watch this. Here's what I would do. And all right, so I have two goals. Real quick. For example, real quick, I want to show you a couple of overriding things. Do you see on part D how there's two fractions here? If I see two fractions, I try to combine them, right? Especially because are there two fractions on the other side? Nope. And I know I want to make one side look like the other side. So if one side has some fractions, I'm going to combine them if the other side doesn't have. Does that make sense? So if I see two fractions, the other side, I'm going to combine those two fractions and hope that some stuff cancels and shit, right? Okay, maybe. Or there's going to be really, really overt. Do I have a identity for this?
Yeah.
Okay, sometimes it's going to be in your face. All right, I'm just going to use that identity right there and then just see what happens. Do you guys? So you got fractions, you want to combine them. You got in your face identities, you use them, right? And then you got stuff like this, which I don't know. See how there's some identity stuff going on? Also, all right, I'm throwing a lot at you. What's the angle on the left side? What angle are the things working with on the left side? 2x. What angle is the right side using? X. So when you notice the angles don't match, you want to use any identity to make them match. Do we have an identity for sine 2x? That we just developed, right? Okay. Again, so I can see the double angle. That's sort of like an identity in my face, but in a larger way, the angles have to match. Or else there's no way it could be equal if the angles don't match. Maybe? Okay, so real quick. On this number one, the way I would have done this number one. By the way, I really want you guys to understand, this is beautiful. Not a damn thing wrong with this. Nothing wrong with this at all, right? But here is the one more thing that a lot of teachers don't think to say and a lot of students don't realize. What is the main difference on the top from the left side to the right side? There's one less cosine, right? I'm going to just divide the top and bottom by cosine immediately, because then I got the top looking correct, don't I? So I thought to myself, if I see something happening over here, I'm going to make it happen over here and hope everything else sort of works out. In fact, it has to. The idea behind this kind of problem is that this equality is true. Say again? Okay. And if you don't, it's okay. You can do the other shit. We already did this problem, didn't we?
Yeah.
You don't have to do it this way. So let's see what I get if I divide. If I start with this side and I divide top and bottom by cosine. So I just divided top and bottom by cosine. So I get cosine x. What is 1 over cosine? Secant x. And what is sine over cosine? Tangent x. See, I'm done? Now, I'm not saying that way that I do it will always be the quickest way. In fact, there are problems where the way that I just did that sucks, right? But there is one more option to realize. I want to make these two the same. If I see something I could do to make the top the same, I do it, and then I work with the bottom like I just did. That is another option. Okay, so keep going. Do the next few, and then I'll catch up to you. And by the way, on part B, I didn't really give you a clue on this. I sort of did. There are so many things you could do here, though. There are a ton of things you could do on part B. So I am just going to let you guys try some stuff. Some of you guys gave up on this one and went to some other one, but does anyone have something they're trying here? Just anything. Yeah, it's almost impossibly wrong unless you say something like, take the square root of both, so don't hesitate to say a suggestion. What are you guys trying? Can anyone tell me what you're trying? It's okay. You could be completely wrong. It's fine. Is anybody trying anything? Or have you guys just been sitting there drawing ducks or something? I don't know. Say again?
Making secant x 1 divided by cosine.
Okay. So one way to do this. So if you take like this side and you make secant 1 over cosine. Sure? And then where'd you go from there?
That's it.
Oh. Now again, I really want this. Remember when we did it over here?
No.
I love it. Thank you so much. Remember when we did it over here? We immediately put stuff together, but then we had too many fractions running around. It's exactly what I have going on here, right? So I can multiply top and bottom by cosine. Right, so it would distribute across here, and the bottom would just become 1. Is that cool? What do I get on the top? I get cosine x times 1. Cosine x times 1 over cosine x. What's cosine x times 1 over cosine x? What do the cosines do? Cancel. So you're there, right? Does everybody see that? I like it because this side's got secants, but this side doesn't have any secants. It's got sine and cosine, so it sort of makes sense to make everything in terms of cosine, because you can, because the other side doesn't have any secants. I love it. But what the shit do you do now?
We're gonna make the other side equal to that one.
Say again?
We're gonna make the other side equal to cosine x plus 1.
Yeah, I love it. Okay, beautiful. So here's the other thing. I think I said this last time. You don't just have to stick with the side you picked. If you also work on the other side and make them meet somewhere in the middle, that also shows they're equal to each other. On the right side, what could I do on the top there? Is there anything I could do on the top?
This 1 minus cosine.
Yeah. Do you notice how, okay, we worked on the left side, correct?
Right.
And we got to here. The only trig in there is cosine, yes? On that side, I have sine, but the only trig on this side is cosine, so it kind of makes sense to rewrite the top in terms of cosine. Because that's the only freaking trig I got on the other side. So like you said, sine squared. So if I work with this side, sine squared is 1 minus cosine squared. And here's where things get really, really exciting. You can factor the top. You can factor the top. Say again? No, they don't both have a cosine. There's no GCF. Isn't it a difference of squares?
Yes.
Don't you have 1 is 1 squared, cosine squared is cosine squared? So real quick thing. What is 1 minus x squared? How do you factor that?
1 minus x.
Kick ass. So what's 1 minus cosine squared?
1 minus cosine.
1 minus cosine?
1 plus cosine.
1 plus cosine. And then what cancels? 1 minus cosine cancels. So what did we get on the left side? We got here, didn't we? Where did we get on the right side? We got here. Are these equal to each other? Yes, we're done. So we made one side look like the other side. Does everyone understand why that means they are equal to each other? If one side can be shifted around to eventually become the other side, they must be equal to each other. That's why 1 plus 4 equals 5, because that can make 1 plus 4 become 5. Yes? Maybe.
Okay.
Oh shit. Oh yeah, I did. Okay, good. Didn't know if I remembered to start filming again. Listen. This is what makes this really difficult to teach and to learn. That is not the only way to do this problem. That is not the only way to do this problem. Completely not. There are other ways to do that problem. Some of them basically come down to be the same thing. Right? Like, what I would have done would have eventually been the same thing as this. But what's 1 over secant? What's 1 over secant? Cosine. Plus, what's secant divided by secant? 1. So this is just cosine x plus 1. I can just see that immediately, right? So that we did eventually get there here, right? Okay, so I really need you to hear what I'm saying. You could choose to try something and it doesn't lead you anywhere. Who cares? That's part of the process, right? In fact, isn't that freaking life? Oh man, what's going on? Oh, there's a leak. Let's try this. It didn't work. What do? Just go, oh well, house is going to fill with water. Let's just go sleep. No, shit, you're going to try something else, right? So it's a part of the problem is that you might pick the wrong thing. Who cares? Now you know that thing doesn't work. Go back and try something else. So what I mean is, like here, I could try to write tangent as sine over cosine. It really does nothing for me. So let me try something else, right? That's kind of like a silly example, but still. What did we say about part C? I did give you a hint on part C. Yeah, what is sine 2x? Now here's the bad part. What's cosine 2x? So many things, right? What is cosine 2x? What's one option for cosine 2x? You all have your paper, you can just read off of it. What's the one option for cosine 2x?
2 cosine squared times 1.
That's funny, because that's the one you want to use. And I want to show you why. But one option is cosine squared minus sine squared, yes? Cosine squared x minus sine squared x. That's not very useful here, really. Another option is 1 minus 2 sine squared, right?
Right.
But why is 2 cosine squared minus 1? Why is that really useful here? Wouldn't that kill that 1? I really want you guys to see this is 1 plus cosine 2x. So if I can rewrite cosine 2x to have a minus 1 in it, won't that kill that plus 1? I really want you guys to see this. And on the other side, does it have anything on the bottom? No, I'm trying to get to have, I don't know if you guys see this, but, so I can rewrite cosine 2x. We're going to choose this option. Right, where did I put this one? Yeah. So what do I get on the bottom now? 2 cosine squared. The 2's cancel, correct? What else cancels?
Cosine.
1 cosine cancels, and what's sine x over cosine x? Done, right? And by the way, when you do these problems in homework, I do want you to kind of like indicate why you're done, right? You draw a little arrow or something. Don't just kind of stop and keep going. Like, oh, we made it. We made it. Okay. So here, I want you guys to try one more thing, because this part D is very, very recipe-ish. But I need to see if you guys can handle the trig algebra. So what did I say to try to do on part D? So combine those two fractions. Do it. They're just fractions. Who gives a shit? We know how to combine fractions. Do it. It's not that big of a deal. What's he got on the bottom? 1 minus sine x. What's he got? So what does he need? What's the other guy got? So doesn't he need 1 plus sine x?
Yeah.
Doesn't he need 1 minus? Okay, go. Not a big deal. Not a big deal. If I had 1/3 minus 1/5, doesn't this guy need a 3 and this guy needs a 5? They both need each other. All right. Same thing happening here.
So you cancel them out.
Well, they don't outright cancel. So I'm going to multiply this side by 1 plus sine x, because that's what he's missing. I'm going to multiply this side by 1 minus sine x, because that's what he's missing. So on the top I get 1 plus sine x plus 1 minus sine x. Is that a cool? What do I get on the bottom? When you multiply this out, what do you get? 1 minus sine x plus sine x. So the middle terms cancel. Minus sine times sine. How are we doing so far? So that's all I did was make LCDs and then put them together. That's all we did. Well, what happens on the bottom? What is 1 minus sine squared? Cosine squared. What happens on the top? What do the signs do? Cancel. What's 1 plus 1? Holy shit. And what do I do to over cosine squared? How can I rewrite that? What's 1 over cosine? Secant. So can't I write this as 2 secant squared? Which is what I want it to be. Oh shit, I'm really zoomed in.
Yeah, you're fine.
So 2 over cosine squared. 1 over cosine is secant, so 2 over cosine squared is 2 secant squared. Yes? And isn't that exactly, I'm done. See, if I just draw the little arrow, that's a great indication that you understand what the hell you just did. You understand why you're done, right? Because you made it look like the other side.
Why do the sign cancel each other out?
Because it's plus sine x minus sine x.
Okay.
Yeah, that's all. Okay, all right. I think that's enough for today. We did a lot today, so I'll let us out a little bit early. Huh? Sorry, man. I didn't do that on purpose, but, real quick. Cosine's the asshole, right? So cosine's like me.
Yeah, cosine y minus sine.
And then sine gets a turn. So the big mistake I see people make is they cross this out and they cross this out, but that's not good. That is so not good. What is being divided by cosine x, sine y? Both of these, right? So if you write this guy over him minus this guy over him, we're basically done. Because now look, cosine x is cancel. What's cosine y divided by sine y? Cotangent y. Minus, here the sine y's cancel with sine x divided by cosine x. Tangent x, there, done. Right? There you go.
I was like, oh, nice.
There you go,
So
okay.
you said 2 fractions, but, oh, okay.
Just to remind you guys again, I see some of you guys taking pictures. The videos are all up on the YouTubes, right? Okay, that's enough.